For example 3, you've got the sine of 13 pi over 12. Now, the three angles that we focus on, the pi over 3, pi over 6, and pi over 4, again, weird order for me to go in, none of those would add up to 13 pi over 12. But what I'm going to encourage you to start thinking about is, think about like breaking it up into two separate fractions that are going to be over 12. They both have a pi in the numerator. And we just got to think about things that we can add to 13. Now, we also want to keep in mind we want to reduce each of these fractions down to, well, angles that are on the unit circle. So I'm going to say, what about 9 pi over 12 and, 4 pi over 12? We can reduce both of those fractions, and we'd end up with the sine of 3 pi over 4 plus the next one would just be pi over 3. So now we can use, this is like our u value, this is like our v value. So we have the sine of our u value, so the sine of 3 pi over 4 times the cosine of pi over 3 plus the cosine of our u value, so the cosine of 3 pi over 4 times the sine of pi over 3. The sine of 3 pi over 4, go into the unit circle. The sine is the y value at 3 pi over 4, so it's root 2 over 2. So I have root 2 over 2. The cosine of pi over 3 is 1/2. The cosine of 3 pi over 4 is negative root 2 over 2. And the sine of pi over 3 is square root of 3 over 2. Cleaning this up a little bit, root 2 over 2 times 1 over 2. We've done that one before. That ends up being root 2 over 4. On the next one, it's plus, and it's going to have a negative in it, so I'm just going to switch it to minus. We got minus root 2 times root 3 is root 6, and our denominator is 4. Folks, we end up with the same answer as we did last time. Coincidence? Kinda, but not really. So the sine of 13 pi over 12 simplifies all the way down to root 2 minus root 6, all that divided by 4. Now the last thing we're going to take a look at here is a little more complicated. There's a lot of things going on here. We have the sine of x plus pi over 4 plus the sine of x minus pi over 4 equals -1. So let's focus on these two pieces separately. We'll leave a plus in between them. In fact, I'll just put the plus over here, which, let me just rewrite this. Let's separate this so the plus is on the right side. And we're going to focus on the sine of x plus pi over 4. Following that sum formula, we've got the sine of x plus pi over 4 is the sine of x times the cosine of pi over 4 plus the cosine of x times the sine of pi over 4. On the other one, on the right side, the sine of x minus pi over 4 is the sine of x times the sine, my goodness, I'm having a problem here, times the cosine of pi over 4 minus the cosine of x times the sine of pi over 4. Now, for consistency's sake, I'm going to put that whole red group in parentheses and the whole blue group in parentheses. Cleaning this up a little bit, we got the sine of x times the cosine of pi over 4. Well, the cosine of pi over 4 is the square root of 2 over 2. Well, actually, before we go any further, take a look at this. This is a whole mess. And it's all equal to -1. Just trying to prove that this is true, or solve that for the x values that make this true. You'll notice there's some repeated things. We got sine of x times the cosine of pi over 4 here and here. And so if we add those two together, we'd have 2 times the sine of x times the cosine of pi over 4. You notice we also have the cosine of x times the sine of pi over 4, and over here we have the minus the cosine of x times the pi over 4. In other words, they gone. They cancel out. So we're left with just 2 times the sine of x times the cosine of pi over 4 equals -1. Now, as we're going through this, cosine of pi over 4, let me switch colors a second. Cosine of pi over 4, if you look on the unit circle, that's equal to the square root of 2 over 2. So it's 2 times the sine of x times the square root of 2 over 2. It's a lot of 2's going on. Now, we can get rid of some of those 2's because it's going to be 2 times something over 2. the 2 and the 2 there cancel out because it's times 2 and divided by 2. So we end up with the sine of x times square root of 2 equals -1. Now, to solve for x, we got to get rid of that square root of 2, so let's divide both sides by the square root of 2. And we end up with the sine of x equals -1 over the square root of 2. Now, -1 over the square root of 2, that's an irrational denominator. We want to try to avoid that as much as possible. So to avoid that, we're going to multiply the numerator and denominator by that square root of 2, which gives us negative square root of 2. And the denominator, root 2 times itself, just gives us positive 2. Let me move this whole simplified version over here. We got the sine of x equals negative square root of 2 over 2. Now you can go to your unit circle. Where does the sine of x equal negative root 2 over 2? There's 2 places. It's down here at 5 pi over 4 and also down here at 7 pi over 4. So we're going to say our x values equals 5 pi over 4 comma 7 pi over 4. Those are the 2 values of x that make this statement true.